I'm going to record this so that I don't have this question later. So if I didn't realize that I have negative 13 plus 6n is the closed formula, then I'd just find the difference between them. And then I'd find a naught as being my first term minus my difference. My first term is negative 7. My difference is 6. And that's where the negative 13 comes from. So there's the negative 13. Going back up to here, if I put everything back in the right place, a sub n is equal to negative 13 plus my n is whatever it is, but my d is 6, so 6n. So as you can see, that even if I didn't know that this is my explicit, I could have came up with the same thing. So with that said, I'm going to stop and say, what kind of questions do you have for me? Just ask.
Nothing.
Brandon?
Yet.
Nothing? Nothing? Okay. So because of the fact that it does stop at n, then, and I'm asked to add up n terms, then I can use these formulas because these are going to add up in terms. So if I'm asked to add this up, this right here is the same thing as saying I have the summation of k equals 1 to n of my closed form, which is negative 13 plus 6k. Because I'm asked to add up the first n terms. And I know it's the first n terms, 1 to n, is because of this right here, this replacement of that k is the n. Or in other words, look, I got my explicit, so I know that's where I end. So what I'm really asked to do is add up the terms between k equals 1 to n of negative 13 plus 6k. Well, if that's true, which it is in this case, then I'm going to use the formulas up above. But first, before I do that, I'm going to rewrite it. So it is the summation of k equals 1 to n of negative 13. And then plus the summation of k equals 1 to n of that 6k.
And why did you do that exactly?
Because I want to use these formulas right here. And the one that's missing is the one that is the summation of k equals 1 to n of some constant. Then this is equal to the constant times k. I should have added that one too. Constant times n, sorry.
Is that one not on our formulas that we had in the notes?
When in the classroom, yeah, that one was on there. For some reason,
okay.
I just didn't put it on this particular homework problem. I should have, and I don't know why I didn't. I don't know why I didn't put that in there.
Okay. Do we put the 6 out front, or should we leave it there?
Yes. So I'm going to pull that 6 out front. I know that this part right here is going to be this formula. So I know that part is just going to be negative 13 times n. Because I don't know where I'm stopping. If I knew where I'm stopping, I would have definitely have just put that 7 or 12 or 100 in. And then I'm just going to rewrite the second part by pulling out the 6. And then I'm going to use this one.
So why do you pull it out front?
You don't have to.
You don't have to?
No, you don't have to. It's just a multiplier. But the reason I always do is when I look at all of these formulas up here, none of these formulas have a multiplier. It's just k, k squared, k cubed, or the constant. And so the 6 has a tendency to muddy the waters, so I just pull it out front because it's just a multiplier.
So would you put k in for n?
Uh-huh. So what this ends up being then is negative 13n plus 6, and then I'm going to use this one right here. But when I use this one, as always, my upper limit gets replaced in, so it actually gets n's get replacing the k's. So I will have n plus 1 divided by 2. I'm going to clean this up algebraically. This 2 and this 6 will cancel, giving me 3. So I have negative 13n plus 3n, n plus 1. And now I can distribute and clean up. So negative 13n plus 3n squared plus 3n. So my final answer that I'm going to put in my homework up here is going to be 3n squared minus 10n. So that's what, so 3n squared minus 10n, and that's what I'm going to put in as my answer. What do I do first? Do I have to?
The sigma line thing with an n on top and k equals 1 on the bottom, and then write 16 next to it, and then minus, or 5. Sorry, I was looking at mine. 5. And then minus the sigma thingy and k equals 1, and then have n on.
Okay, but yeah. Now what? I'm going to give you this one again.
Now we'll go 5n.
So this is equal to 5 times n. Then what?
And then put a minus sign, and then k, and then n, exactly the first equation.
This? Right here?
Yeah.
Okay.
And then that would be negative n squared minus 1 over 2. Minus 1. Oh, minus n, you're right, sorry. Is that it?
Yeah, you can write it just like that. So in here, what you would type is 5n minus parenthesis n squared 2 plus n parenthesis divide by 2. So that would be the equivalent to what we just wrote.
Weirdly enough, it's making so much more sense now.
Yeah.
Good?
Why is it? It's like one-on-one. I feel like I just like connect more.
That's why I hold office hours. Some people can do it just by listening and watching and not having to ask the questions. Some
That's
people
literally Sydney.
Yeah. And some people need that extra one-on-one. That's why I give you an hour and a half office hour Monday through Thursdays, so that I can, if you need it, have one-on-one. And on Monday through Friday, if you all want to make an appointment with me between 10 and 10:50, I have that office hour open as well. But that's mostly for appointments. So if you need one-on-one, then just let me know Monday through Friday from 10 to 10:50.
Oh, cool.
What other... Look at this. What is the first thing I want to do when I take a look at this and I'm asked to find the summation? What's the first thing I want to do?
You want to find a closed formula?
Exactly. I want to find a closed formula. Now I see it alternating. So typically what I do is I ignore the negative part because it's alternating sequence. So ignoring the negative part, if I were to just give you 3, 5...
You're going up by 2.
Yep. So if I'm going up by 2, so plus 2, ignoring the negative part of it, how would I find the closed formula for this arithmetic?
A sub n equals a sub 0 plus nd.
How do I find a sub naught?
Your first term subtracted by your difference.
So now that I've found a sub
It's
naught,
-3, right? Or are we still ignoring them?
we're ignoring the negative for a moment.
Okay.
So my a sub naught is 1. So how am I going to rewrite my a sub n now?
A sub n equals 1 plus 2n.
Okay. So that is the part where it goes from 3 to 5 to 7. Now, how do I get this to alternate? So here's my true one.
Wait, is it... yeah, and... oh, minus... okay.
And how do I get it to alternate? Having the first one be a negative. Is the power going to be on the negative? Is it going to be to the n? Or is it going to be to the n plus 1?
Would it be the -1?
But this is a -1, this power right here that I'm going to write in a minute, is that raised to the n or the n plus 1?
N plus 1. Question mark.
So question mark. This is how you check. If I put in 1 right here, right? So I have to have my first term. If I put in 1, I have -1 raised to the 1 plus 1. So -1 raised to the 2. Is that going to be a positive number or a negative number?
Negative?
-2 or -1 multiplied by another -1?
Oh, that's positive.
It's okay. It's positive 1. So is it going to be, and this is, I'm glad that you are struggling with this,
Oh gosh.
because it is a learning experience. Is it going to be n plus 1 then?
No, it's gonna be N minus 1.
Okay. So let's see if that works. So let's do n minus 1 question mark. So let's try this in green. So I have -1 raised to the 1 minus 1, which gives me -1 raised to the 0, and anything to the 0 power is positive 1. So is it n minus 1?
Yes.
Is it n minus 1?
No.
Okay. So what do you think it is then?
I honestly have, is it cubed? I mean, is it squared?
No. So my choices are this. So this choice, this exponent here, these are my choices. I can have n minus 1. I can have n. I can have n plus 1. Those are my choices. I'm going to choose a bunch of other things, but those are the easiest choices. We've chose this one, and it doesn't work. We've chose this one, and it doesn't work. What do we have left over?
It's gonna have to be N.
Yep. So let's check it. So I'm going to check it up for 1. -1 raised to the 1. Does that give me a negative number?
Yes.
Yeah. So your choices are really just these two. Either we have n, or we have n plus 1 on alternating series. So if I have -1 raised to the n, I use this one when I want my first term to be negative.
Okay.
And I use -1 raised to the n plus 2 when I want my first term to be positive. So those are really just the choices I have. So now that I've found my closed formula.
Wait, what about the N minus 1? I'm confused on what that gives you.
Well, n minus 1, let me put that back. If I were to have used -1 raised to the n minus 1, when n equals 1, then I have -1 raised to the 1 minus 1. So -1 raised to the 0. We have this rule, a to the 0 is equal to 1 all day long, provided a is not equal to 0.
So it's just 1
Mm-hmm.
every time.
So we don't typically use the n minus 1 for the alternating, for the negative part. We can use it if it's part of the ratio, but it's an alternating sequence, so we're not going to use the n minus 1. We typically only use these two here. Okay, so we found the closed, right? So we found the closed. The closed is going to be, the way I would put this in, is parenthesis 1 plus 2n, n, or -1 raised to the n. So now I've found the closed formula. So I found that part of it. Where do you think I'm going to start?
We're going to start at -3.
So I want my first term to be -3. So what do I need to put in? What do I need to put in right here?
One.
Mm-hmm. So I'm going to start at 1. Now I need to figure out where I'm going to end. So the way I figure out how many terms I have, I can just count them. If I don't have the ellipses in there. How many terms do you see?
10.
Okay. So that's where you end. So if you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, that tells you how many terms you have. If you had those ellipses, say you would have had -3 plus 5 minus 7 plus ... and then 21 plus 21, then that's a different story. I can't just count them, right? I'd have to figure out how many terms happened. If I had this with these ellipses right here, then what I would have done is I would have put 21 is equal to my closed formula. And I would have solved that way. But they're all listed, so I don't have to do that. I can just say, oh, I have 10 terms, so that's what I have.
It's okay. I was putting it in with you, and it says that n is not defined in this context. Should I use k?
Oh, yes, sorry, k. It should be k.
You're good.
And the reason it's k instead of n is because it is the closed formula of this series. Erase that. Erase. Of the series, not the sequence, so that should be to the k. The difference between the closed formula for the sequence is that I will use n's typically. But if I'm asked for the closed formula or explicit for the series, then everywhere I see an n right here, I'm going to replace it with whatever that variable is being used as the dummy variable. So if that would have been j's, I would have used j's. If that would have been m's, I would have used m. But it's a k, so I replace here in my closed or explicit with that dummy variable. And that's why it should be k.
That's confusing.
Well, that's because k equals 1, k equals 2, k equals 3. And when I see the summation, it just means I'm adding them. So the difference between this, the summation of k equals 1 to n, of 1 plus 2k, -1 raised to the k, and a sub n is equal to 1 plus 2n, -1 to the n, is that this is equal to, I'm going to take all of my terms and start adding them. So the first one is -3 plus 5 plus a -7 plus ... plus 21. So I've put in k equals 1, k equals 2, k equals 3. This one, when I see this one, it would be -3, comma, 5, comma, -7, comma, ... and it's not ending. So
Okay.
one is when I see this, means I'm going to add up. When I see this, I'm just listing them. But notice the first terms match, the second terms match, the third terms match. So there's a match between this and this and this and this and this and this. But the difference is I'm either adding them or I'm just listing them.
And in this case, I was just adding
Mm-hmm.
them.
Right. And so it is the same formula. One has n, one has the dummy variable k, or whatever the dummy variable is, but it's the exact same formula with just a variable change.
Okay, I get it.
Okay.
Thank you.
Yeah, absolutely. What other kind of questions do you have for me? How did you get 210? How did you get 210?
20 times 21 divided by 2.
Okay. How did you know it was 20 times 21 divided by 2?
I subbed the last one n for n.
Okay. So what you did was you said, okay, I'm going to use this formula right here. And I know that if I use that formula, it is my last term, which is going to be 20. And then it's going to be 20 plus 1 divided by 2, which gives me 210. How did you get this one?
I got j
What did you use?
times by j plus 1.
Why did you use j? I'm not saying it's wrong. Why did you use j? How did you know to use j?
It was the last term.
Okay, this is my last term, so you know you're going to come up here and you're going to replace those n's with your last term. So it is j, that's a j, not a y, j plus 1 divided by 2. So you multiplied it through, and you got j squared plus j divided by 2. How do you think you're going to do this one?
This one's a little bit different. Would you do, like, I tried it, but I don't think I got it right. Was it k plus, in parentheses, k plus 1 multiplied by k plus 1 plus k plus 1?
Yep. So
Yeah,
everything.
you literally just read that out and put it in.
So.
Wait, did you forget the k though?
So you told me that this is my last term. So if that's my last term, then I replace this in with k plus 1. And I replace this in with k plus 1.
Oh.
So I'm just going to just rewrite it just a little bit so I don't have a bunch of parentheses. So k plus 1, k plus 2 all over 2. And all I did was I said, hey, you know what? This parenthesis here, and here can come off. And I can just add the 1 plus 1, I get k plus 2.
I guess I was just confused because I thought the k before the k plus 1 in the parentheses in the equation, I thought that was also included. So I was doing like really long algebra.
It would have came out to the same answer once you simplified, but the real thing that you are looking at is because they put this in parentheses right here. That's how come I knew that was the last term.
So they just put the plus k to fool with me.
Yeah, so this really didn't need to be there. But the reason it is there, though, is that it tells you that you had a term behind it that was just k.
So with the next, let's say there's ellipses after the k plus 1.
Mm-hmm.
Would it be k plus 2 and then k plus 3?
Absolutely, yes. Absolutely.
Okay.
When we're trying to determine whether we have a geometric series or not, how do I know it's a geometric series? What has to hold true for this to be a geometric series?
A2 over A1 equals A3 over A2.
Yeah, so I have to have that ratio. So a to the n plus 1 over a to the n has to hold for each term. So I'm going to check to see if this holds right here. So I'm going to check to see if those hold. So I'm going to do the ratio of, I'm going to do 3x to the 5th over 2x to the 4th. Then I'm going to ask myself, does that give me the same answer as 4x to the 6th divided by 3x to the 5th? And then I'm going to continue down the line. So I also have to make sure that 5x to the 7th is going to be the same thing as 4x to the 6th. So I get 3 over 2 just doing that part of it, and then I have an x in the numerator. Does that equal the same thing as 4 over 3 with x in the numerator? Does that equal the same thing as 5 over 4 with x in the numerator? Are those all the same numbers? No. So the answer is no. And then it says if it is not a geometric ratio, then the first term, enter NA for the first term. NA is what you're going to put her in there for that. And then if the ratio is not, so we just put NA there. And we may have to put NA there too.
Okay. Can we do one where it answers the second question? Because I guess that's where I'm confused on what it means by successive.
So now let's just look at this second one. So I'm going to do the same thing. I'm going to do 2 over 2 over 2 is that equal to the same thing as 2 over 3 over 2? Is that the same thing as 2 over 4 over 2 over 3?
No.
No, because I get 1/2 for the first one. That reduces to 1/2. The second one is going to be 1/3. And I can just stop right there. So the answer there is no. I put NA here and I put NA here. So let's take a look at our third and final one. Is my third and final one, again, I'm going to do the ratio, and so I'll do this in red. I have 2x over 1. Is that the same thing as 4x squared over 2x? Is that the same thing as 8x cubed over 4x squared? Are those all the same?
Yes.
Yes, so that is a yes. So the first term is 1. That's this. And then what is the ratio? Because you said these are all the same. What is that ratio that you just found it to be?
Would it be 1x over 1? I mean 2x over 1.
Yeah, or just 2x.
2x. Oh, okay. Oh, good, okay. So it was just wanting the ratio.
Uh-huh.
Okay.
What else can I help you with?
I think... Ooh, can we do 9?
Number 9. So for this one, what we have to do is we have to notice that I'm not starting at 1. So all
Yes.
of those formulas that I have when I see n squared n or a constant, it does not start at 1. So I have to do the entire sequence and pull off the first 5 terms because I start at 6.
Okay.
So this I'm going to rewrite as n equals 1 to 28 of negative 2n squared minus n plus 9. And I'm going to pull off the ones I don't want. I don't want terms 1 through 5. So I'm going to pull off n equals 1 to 5. I don't go to 6 because I want the 6th term. I want the 6th term, so I'm always going to choose one less than what I really want. Of negative 2n minus n plus 9.
And the 2n squared, right?
Yep, sorry, 2n squared, yep.
You're fine.
And then I'm going to use those formulas, but before I use those formulas, I am going to break it apart. So I have the summation of n equals 1 to 28. I'm going to pull out the negative 2, so I just have the n squared. Minus the summation of n equals 1 to 28 of just n. Plus the summation of n equals 1 to 28 of 9. And that, all of this is just that. Now I'm going to do the second one, I'll do that in red, so I have minus, I'm going to put a parenthesis here, negative 2, the summation of n equals 1 to 5 of n squared, minus the summation of n equals 1 to 5 of n, plus the summation of n equals 1 to 5 of 9. And all of this represents that portion.
Okay.
And if I want to, I can pull the negative through. So I'm going to go ahead and just pull the negative 2 through. So I have negative 2, the summation of n equals 1 to 28. The only reason I do this is so I don't forget it later. And then minus the summation of n equals 1 to 28 of n, plus the summation of n equals 1 to 28 of 9, plus, because the double negatives, 2, the summation of n equals 1 to 5 of n squared, plus, because I'm pulling, what I'm doing is I'm pulling this negative through, and that's only so I don't forget it. The summation of n equals 1 to 5 of n, and then minus the summation of n equals 1 to 5 of 9. And then I can use those summation formulas and put in 28 or 5. So let's go ahead and just do the first one. So this first one is -2. The formula is generically for the n squared, I believe, was n plus 1, 2n plus 1, all divided by, I think it was 6. I think that's right.
I think that's right.
Okay, so then wherever I see n right here, I'm going to replace those with 28. So this is going to be 28 plus 1, 2 times 28 plus 1, all divided by 6. And I can just put that in my calculator. And then minus, I believe when I had n, it was, so when I see n, I think this one was n plus 1 divided by 2. So I have minus, I'm going to replace the n's with 28, so minus 28 plus 1 divided by 2. I like the constant because the constant is just plus 9 times 28. Now all of these terms right here, which are nice numeric values, are replacements for these 3 terms. And then I'm just going to repeat it, but instead of using 28, I'm going to use 5 because my upper limit is 5. And of course, I'm going to use my calculator.
And I add them all together.
Yep. So you're going to get your calculator out and you're going to figure out what this number is. You're going to figure out what that number is, figure out what that number is, and then you're going to add whatever this ends up being as number, whatever this ends up being a number. I can tell you that one's 45.
Oh, because it's 5 times 9.
Mm-hmm.
Okay. I will get to that then.
Okay. Any other questions you have for me?
I think that's it.
Okay, cool. I will actually, if you're okay with this, I'm going to upload this particular video into our classroom so that other people can take a look at some of the examples we worked today.
That's okay with me.
Okay, cool. All right. If you don't have any other questions, you all have a great afternoon. I will be available until 2 o'clock, however.